Welcome everyone to the 8th grade Unit 4 quiz review video on solving linear equations in one variable. Okay, it's a quick quiz that just tests you can solve equations. So we'll get right in. Question 1, solve the equation for D, show your work. So here we notice we have variables on both sides of the equation. We also have numbers on both sides of the equation, constants. And we want to try to get rid of stuff so that we get more simple, right? We want to just have variables on one side of the equal sign, and we want to just have constants, normal numbers on the other. So personally, I think I would do this by getting rid of the minus 10 first, but we know that's not the only first step I can do, right? So I'm choosing in this case, let me get rid of the minus 10. And when I do that, on the left-hand side, I have 5d minus 10 plus 10. So the minus 10 plus 10 goes away. I'm just left with 5d on the left-hand side. On the right-hand side of the equal sign, I have 30 plus 10. That's going to be 40. And then I still have my minus 10d. Remember that plus 10, right, that's a normal number 10, just a constant. So we can only combine that with normal numbers, constants. We can't combine it with variable terms. Okay, now at this point, I only have a constant 40 on the right, but I have these variable terms 5d and minus 10d on both sides. So I'm going to pick the minus 10d to get rid of. I'm going to add 10d on the right so that I'll only have a number on the right, and I'll add 10d on the left. And that's going to make me only have the variable term 15d on the left and only have the constant term 40 on the right. Okay, because the minus 10d plus 10d goes away to 0. And then lastly, I have that d, my variable, is being multiplied by 15. So I'm going to do the inverse operation of multiplying by 15, or the opposite. I'm going to undo multiplying by 15 by dividing by 15. When we do that, we're going to get that d is equal to 2 2/3, or 2.6 repeating. Okay, and this is a good example. You're not going to be able to come up with that number in your head just looking at the equation, right? You have to go through these steps to try to simplify to figure out what d has to be. Awesome. All right, moving on to 2. We have Amani and Esteban each have different audiobook club memberships. Amani's book club costs $8 for the membership and then $5 per book. This can be represented by 5b plus 8, where b is the number of audiobooks purchased. Esteban's book club costs $29 for the membership and then $2 per book. This can be represented by 2b plus 29, where b is the number of audiobooks purchased. Solve the equation to determine after how many audiobooks both book clubs cost the same total amount. Okay, so ultimately, all you have to do is solve this equation, right? But we're seeing an example of solving equations in the real world where you have two different scenarios and we set them equal to each other because that's going to tell us when they cost the same amount, right? So if you buy less than that many books, one of them will be cheaper. If you buy more, the other one will be cheaper. But this is when it's going to be like the same, okay, for either book club. Okay, so the same thing. I can pick one of these terms, 5b plus 8, 2b plus 27, and try to get rid of it. In general, to try to steer away from negatives, I pick either the smaller variable term to get rid of or the smaller constant term. So I here would probably get rid of either plus 8 or the 2b. We'll go with the 2b this time. So I'm going to get rid of 2b on the right by subtracting away 2b. Then I have to do that to the left-hand side of the equal sign, subtracting 2b. Right, I put the minus 2b under the b terms because those are the like variable terms. I can't put it under a number, right, and try to subtract it from just a normal constant because it's not the same thing, not the same like term. On the left, I have 5b minus 2b, which is 3b, and then I bring down my plus 8. Okay, at this point, I have that plus 8 and I have a 29, so I have constant terms on both sides. I'm going to get rid of that plus 8, subtract 8 from both sides, and I'm going to get that 21 equals 3 times b. And then finally, b is being multiplied by 3, so I'm going to divide both sides by b, and I'm going to get that b equals 7. B here represents the number of audiobooks purchased. So this means, to answer the question, that the book clubs will cost the same amount after you purchase 7 audiobooks each. Cool. Okay, so these were the mild level questions because we didn't have to distribute or deal with parentheses at all. Questions 3 and 4 are the medium level questions because we have these parentheses. Okay? All right, so when we have parentheses, we have to apply the distributive property, or that's one of the methods, but it's the common one we do. So we multiply the number outside of the parentheses to the 2 terms inside parentheses, because 3 times the quantity 4x plus 8 means we have 3 groups of 4x, which is equivalent to 12x, you're multiplying, and 3 groups of 8 means we have 24. Okay, so all we have to do is multiply that 3. And then at this point, I noticed that I have a 12x and a 4x. And so I have x's on both sides of the equal sign, right? So because of that, I don't want to get rid of my plus 24 because that's not actually helping, because that's the only normal number I have, the only constant. I want to get one of these variable terms away because I have variables on both sides. So what I'm going to do is I'm going to take away this 12x. I'm going to take away this 12x on the right-hand side too, because then I'm going to end up with a really basic equation that 24 equals 2 times x. Okay, and at that point, all I need to do, x is being multiplied by 2, so I'm going to divide by 2. If 2x's equals 24, then 1x equals 12. And that's my answer. Okay, so that's again this key step of recognizing I want to take away 12x. Because I want to make it so that I only have x's on one side of the equation and I only have constants, numbers without variables, on the other side. Okay, 4 looks a little bit more complicated, but the process is the same. Take it one step at a time. We have parentheses, so we can use the distributive property anywhere we have these parentheses. We have negative 3 times 7, that's negative 21. And then we're going to add negative 3 plus times x. So that's either going to be plus negative 3x, or we could write that as a minus 3x, right? All that matters is that within there you either have like, it's a negative 3x or you're subtracting 3x, which are mathematically equivalent. Okay, and then here we have 2 times x plus 2 times 4, which is 8. Okay, at this step, the easiest thing to do would be to combine like terms. So this is a negative 21, and this is a negative 6. And those are on the same, or a minus 6, however you want to see it. Those are on the same side of the equal sign, so we can take those together, right? We're not doing it to both sides of the equation because we're just sort of putting together things that are like. So when we have negative 21 minus 6, that becomes negative 27, okay, or minus 27, however you want to write that. And then we still have the minus 3x. So again, this is merging right there. Okay, and then we bring down the minus 3x and the negative 3x. And then on the right, we have our 2x plus 8. We haven't done anything over there. And now it's just like the questions from above. Pick something, get rid of it. I'd probably get rid of the minus 3x by adding 3x to both sides. But again, this isn't the only correct way of doing it. You'll get negative 27 equals 5x plus 8. Okay, and then we're going to subtract 8 from both sides because we want to get only numbers on the left and only variable terms on the right. 8 minus 8 goes away. This becomes negative 35 equals 5x. Remember, you want to take your time, use a calculator if you need to do that minus 27 minus 8. People just make a lot of mistakes on that. And I don't want you to get the question wrong because of a negative error. Okay, and then finally we can divide both sides by 5, and we'll get x is negative 7. So, it takes more time, but the process is the same. Get rid of the parentheses. We can combine like terms to simplify it a little bit, and then undo what's there. Try to use inverse operations to get rid of things so that we isolate x and figure out what it is. All right, last two questions are spicy level questions. This part of the standard is recognizing when we have equations that have no solutions or equations that have infinitely many solutions, meaning any value of x or no value of x will make the equation true. So in question 5, we have to select all of the equations that are true for no values of x. Okay, I'm just going to skip around and look at the ones that look obvious to me. 8 equals 6. Does 8 ever equal 6? No. Okay, so I guess I should make it clear. I'm going to select it. I'm going to check it off. Right? Check. Now I'm kind of going back and forth. Okay, shaded in. That one is correct because 8 doesn't equal 6, right? And there's no value of x that can make 8 equal 6. 8 just doesn't equal 6. Okay, so that one's definitely not true. For the rest, we might need to do a little bit of work. So on the first one, we have 3x equals 7x. That does have one solution, and the solution is x equals 0. So we could try to solve that by like subtracting 3x from both sides, and then we get 0 equals 4x, and then you divide by 4 and x equals 0. So this one isn't going to be correct. This one has one solution. The solution has to be is x equals 0, so that makes it a little bit confusing, but there is one solution. There's some value of x that'll make it true, so it is not our answer here. Okay, going below, we have that x plus 12 equals x plus, in parentheses, negative 3 times 4. Negative 3 times 4 is negative 12. Okay, so this is going to have no solutions because you have the same variable term of x, and then once we're adding 12, and at another point we're adding a negative 12, so those aren't the same thing, right? Adding 12, subtracting 12, or adding a negative and a positive doesn't give us the same thing. We could show that by subtracting x from both sides, and then we'd get something like 12 equals negative 12. And that's not true, right? 12 never equals negative 12. They're not the same number. So that is going to be correct. No solutions. Next one, we have parentheses, 4 times the quantity x plus 2. That becomes 4x plus 8 equals 4x plus 2. This is also going to have no solutions. We have the same 4x on both sides. If I'd want, I could subtract it away from both sides, and then I'd get another false equation, like 8 equals 2. Right? That's not true. We're not going to get that ever. No value of x can make x equal 2, so there's no solution. All right, moving on to this one, we have 10 minus 8, that's 2, plus 7x equals 3x plus 4x, that's 7x, plus 5. Again, this is going to have no solutions. This will be one of our answers because we have the same 7x on both sides, so we could take away 7x, and then we'd get a false statement. 2 equals 5, right? And 2 never equals 5. No value of x is going to make 2 equals 5, so that can never be true. Okay. And then finally, we have parentheses, so we can use the distributive property. Don't get stressed by the fact that it's a fraction. If you don't know the math in your head, you can just use a calculator or by hand. We're doing a half times 2. A half times 2 is 1, so this becomes 1x. And then we do a half times 9, that is 4.5, equals 1x plus 4.5. This is going to have infinite solutions, or infinitely many. Any value of x is going to make this true, because we'd get 4.5 equals 4.5 if we subtracted 1x from both sides, which is always true. Okay, so the last one is always true, so it's not correct, and the first one has one solution, so that's not right. So it's definitely a tough question. You just got to simplify the equations as much as you can till you get to either until you get to something that you can solve. Like here, you can get x equals one number, or you get to an equation like this, x equals 8 equals 2, which is never true, or you'd get something like you could have gotten there. If I write it, we could have gotten to 4.5 equals 4.5, right? And then that's always true. Okay, and on that point of being always true, question 6 says, write an equation with infinitely many solutions. Explain or show how you know it has infinitely many solutions. So we have infinitely many solutions if we're basically have two equivalent expressions that are equal to each other. So we're talking about the exact same thing. Okay, so in this case, you can just make anything up you want. My favorite numbers are 2 and 18. So I could write the expression like 2 times the quantity x plus 18 equals, and then what is that going to equal? It's going to equal 2x plus 36, because I'm doing 2 times x and 2 times 18, which is 36. Okay, that is going to be my answer, and that is always true. So it has infinitely many solutions, and they say like explain or show how you know. So then I can show that this equals 2x plus 36. So I have 2x plus 36 equals 2x plus 36. I have equivalent expressions on both sides, and I could do another step further, and I could get like 36 equals 36, right? Which is always true. These are equivalent expressions. Okay, you could make it more simple than that. Like you could also write like x plus 5 equals 5 plus x. That's always going to be true. All infinitely many solutions. There are lots of different ways to do it. Okay, and that's it. That's the quiz. I'm available after school. If you want to get some help from me, I would love to help you. Good luck, everyone.